welcome to the last video of this module. And this module, you got a little something different. We're not going to have a lot of notes per se. What I'm going to be actually doing is I'm going to be covering some really tougher problems on your last set of homeworks that I really feel like a lot of students struggle with. And in order for us to do that, I want you to understand that we're talking about two subjects here. One is called volume. Volume, if you could remember back from your grade school days, is basically how much an object, space an object takes up. So I have a calendar here, it takes up space. And the way we know that is because it's a three-dimensional object. It has a length, it has a width, and it has a height. And because of that, it takes up space. And when we measure it and we do all the mathematical mumbo jumbo with it, the units that we discuss it in is always unit cubed. So if this was in inches, our answer would, if we were measured this calculator, it would be inches cubed. If we measured it in centimeters, it would be centimeters cubed, etc., etc. All right, so that's really what volume is how much space a 3D object takes up. Now, here's the cool part about this. Here are all your equations, all right, the end. I will tell you this, all right, and it is important that all of these equations that you see come from this one equation. Volume equals capital B times little h. This is not on your equation sheet, and you can put, I would suggest that you put it up there because it can help you. But what is this telling me? Everything else that we have used has little b. Well, big B in this case means area of base. All right. What do I mean? I'll explain that in just a second. Well, h we already know. That's our height. All right. From this one equation, all of these stem from it essentially. I mean, that's really what it boils down to. We could do all the math to prove that this and these are the same thing, but I'm not, and you don't want me to. All right. Now, I will tell you this. Notice that I have a box, a volume for box, and then volume for cube. If you can't remember this one for cube, this one will always work. If you have a box, it doesn't matter what shape of the box is. If it's a normal size rectangular box, this equation right here will always work. All right, so we are going to come back to this topic a little bit later in the video. Now, the other thing that we're going to just mention here is surface area. Surface area is the total amount of area that the outside of a 3D object has. Well, what do I mean? All right, so going back to my calculator. Well, if we were looking at it flat on, we could calculate the area of just the top of this calculator by multiplying the length and the width, right? Well, that would give me the area of just this one side. But I don't want the area of just this one side. I want the area of the top, the area of the bottom, the area of this side, the area of that side, the area of this side, and the area of that side. Once I know all of 6 of those sides and their areas, I add them together to get what we call the surface area. If that's confusing, think of it like this. Surface area is basically like taking wrapping paper and wrapping the object. How much wrapping paper can go around the object? That's a good way of looking at surface area. Surface area, just like volume, I've given you all the equations. Here they are. Here's the cool part about both of these things. If you have an object and you're told to calculate the volume, look at your formula sheet. Find the object. If it's a pyramid, you're going to use this equation, plain and simple. If you're asked for surface area, there you go. That's a right circular cone. Plain and simple. Now, I will tell you this. Notice that these two have parentheses. This says circular cylinder including top and bottom. What that means is this. If I have a can, I am going to be calculating how much paper can go around the can, like this, how much paper can go on top of the can and on the bottom of the can. That's what that's saying. How much surface area does the entire can cover? This one says a right circular cone, not including base. So I have a cone here. Alright, what this is saying is that this equation calculates how much paper can go around the outside of the cone, but not on the bottom of the cone. Alright, just want you to understand what these two are saying. Alright, so that's kind of enough about what these equations are about, and you've got those already. Now let's get to your actual quote-unquote notes. We're not going to be doing note-taking. It's just pretty much common sense on these first part. Look, this one is literally telling you to find the surface area and the volume. The same thing with this problem. What I want you to do is I want you to try and do those two on your own. So for these, you should have got the surface area was 368 centimeters square. The volume is 420 centimeters cubic square. Now, why is this square and this is cubic? Alright, now here's the reason for it. This is area. Remember a while ago when we were calculating, kind of showing you the calculator, excuse me, I'm stuttering real bad. We found the area of the top, the bottom, and the side, and each of the sides, and then we were going to add them all up. Well, area is always going to be units square, so surface area is the same thing. Volume, on the other hand, will always be units cubed. Alright, then for this cone you should have got 54.93 inches square, and then for the volume you should have got 47.10 inches cubed. Now, I also want you to go ahead and look at these next two. However, in making this video, I didn't notice until just now that you actually have a formula that is missing. You can do, it's for, for this one right here, for the sphere, it asks you to calculate surface area. Well, you do not have that on your formula sheet. So, you do need to put this on your formula sheet. Sphere is, the surface area is 4/3 times pi r cubed. Alright, so I cannot stress this enough. Please put this on your formula sheet, okay? I don't have it up there, and I apologize about that. So sphere, the surface area is 4/3 pi r cubed. So what I want you to do is I want you to look at these two pictures and do exactly the same thing. I want you to pause the video, try these on your own, and then come back and see how you did. Alright, so for the surface area of this cylinder, you should have got 1,884 square centimeters. And then for the volume, you should have got 3,532.50 cubic centimeters. For the sphere, your surface area is 16,277.76 inches square, and your volume is 195,333.12 inches cubed. Alright, those should be your answers on that. Now again, I'm not spending time on this because I feel confident that you can plug in the numbers into the equations and kind of solve it on your own. However, if you're struggling with this, please come talk to me and I'll help you out. Now what we are going to spend some time on is this. This I am going to go by little, and I apologize that you can't see this picture very good. Let me see if I can try to make it a little bit darker while I'm talking to you. Sometimes we're going to get weird shapes, and what our job is to do is to calculate the volume, and those weird shapes don't have an equation for them. Alright, and what we end up getting is really, it just becomes a problem, is that it doesn't fit our rules that I've given you. Hopefully you can see that just a little bit better. Alright, so how do we go about solving this? Well, I want you to kind of think back to the beginning of the video. I told you that all volume equations stem from this. V equals capital B times H, where B represents the area of the base. Well, what's the base? Well, the base is basically, for lack of a better word, the bottom, okay? Whatever the 3D object is sitting on, that's generally the base. Maybe not entirely true all the time, because we're going to see some other problems where the base is not what you're sitting on. But nevertheless, this is what you need to know. If you know the area of your base and you know the height of that object, well, you simply just multiply it. So I can simply say that I'm going to say 25 times 6. When I do 25 times 6, not minus, times, gives me 150. That means that the volume of this weird looking shape happens to be 150 foot cubed. 150 foot cubed. Now there is a little other question that goes along with this, and it says, identify the problem solving method that should be used. Choose the correct answer. Do we draw pictures? Well, that's a waste of time. Relate new problem to an older one? Try a simpler version of the problem? Be systematic. I'm just going to give you the flat out answer to this, and I'll explain what happened because you just did it and you don't even know it. We're going to take this new problem that you've never experienced before and relate it to something you kind of understood. We talked about this a while ago, base times height. That's really what we've done. Alright, now let's go to the next one. This one and these two right here are the ones that you can pretty much guarantee being on your test. I'm just going to tell you flat out. And so what we're going to do is we're going to talk about it. Remember, in order to calculate volume, it's either most everything falls under either A, those equations that are on your formula sheet, or it's going to fall under this. Well, there is no shape on that equation sheet that's this. Doesn't exist. But this does. So our question that we have to ask ourselves is, what is our base? Well, in this particular shape that we have here, our base is actually a trapezoid. So we need to find the area of our base, which is this trapezoid right here. Okay? And I can't highlight it very good. Okay? Now, go back to, I think it was our second video. Recall that our trapezoid's equation happens to be this. Base 1 plus base 2 times height, divided by 2, all multiplied by the height. So what we're actually finding is that B, the area of the base, which is a trapezoid, is going to be base 1 plus base 2 divided by 2. Matter of fact, let me make that a little bit easier to read by getting rid of that. So it's divided by 2 times height. So what goes where in this particular problem? Well, let's make sure we understand what our shape that we're looking at. We're looking at the trapezoid. So what are our two bases? Well, bases are always parallel. So we're looking at this line right here and this line right here. Well, this line we read to be 8 inches. So our base 1 happens to be 8. This line here is the same as this one. So we know that that's going to be 13 divided by 2. Now, we're done with these two numbers, so we can kind of just scratch them out, and I'm going to do that with a different pen just so we can see it. So the reason why I'm scratching them out is when we do these problems, you need to realize we don't always use the same numbers. And if you don't scratch them out, you may use the same number twice by accident. So you already know what your two bases are. The problem is height. A lot of people look right here because yes, this is the height of the entire 3D object, but it is not the height of our base. Remember, our base is all we're looking at is a trapezoid. So if we just looked at the base really looks like this. And so this is kind of like a bird's eye view. you know that this side is 8, this side is 15, and since you're looking at the top of this 3D object, your height is really right here, and in this case happens to be 8. Alright, so this number, even though it's the actual height of my three-dimensional object, it is not the height of my base that I'm trying to calculate. So I'm going to put 8 in our little equation over here. Alright, and now I'm going to just plug all this in our calculator. Alright, 8 plus 13, divide by 2, multiply that by 8, and we find out that B is equal to 84. 84 what? Well, our units happen to be inches, and since we were finding area of that base, it's inches square. Now, are we done? No, we're not, because this found the area of just this one side, just this base. We want the volume. So now we can look at this. We already know what B is because we've calculated. So what's H? Well, H is the height of the entire three-dimensional object, which in this case happens to be 7. So V equals 84 times 7, and we find out that 84 times 7 is equal to, excuse me, 588. 588 what? Inches cubed. Now this one, like I said, is complicated because you have to think in three-dimensional terms. 1, this is a three-dimensional object. 2, it has a trapezoidal base. So you have to find the area of your base. Once you know that, you multiply the area of that base times the height to get the volume. Otherwise, basically this equation. So we had to kind of use a little bit of common sense. Alright, same principle for this problem right here. Okay, so first off, we know we're going to have to use this equation again because there is nothing in our formula sheet that shows this particular problem. It's just not there. However, I do know I can find volume by base times height. So what is my base? My base happens to be a triangle. But what kind of triangle? So let's look at it. Let's pretend I'm a bird and I'm flying over this thing. And this is my shape, okay? When drawn out, looking at it. It says that the short side is 8, and this is inches. This side is, oh wait a minute, that's actually the long side, but anyway, it's okay. This is not accurate details. But notice this side was 8 right here, so I kind of drew it as a triangle. This side here was 7, so there's that, and this side here is 7. Yes, this is not drawn to scale. Hey, it's alright for our purposes. This is what you need to understand though. What type of triangle is it? I happen to know that this is a 7 and this is a 7. So two sides are the same. What does that mean? It means that I have an isosceles triangle. So now we got to go back all the way to our triangle theorems and equations and all that wonderful stuff. So we need to recall what our equation for isosceles is. The isosceles triangle equation goes like this. It states that the area, and we're going to put B here instead of because that's the area of our base, is going to be 1/2 times little b times the square root of a square minus b divided by 2 in parentheses square. Alright, so this was our equation. So our job is to put all of this information here. So recall back, our b, little b, happens to be the side that's different, and our a happens to be the sides that are the same. Alright, now because I'm running out of room here, we're going to try to simplify matters just a little bit more on the side here. And I apologize. If you want to, you could write this on another piece of paper, but this is really important. So I'm going to kind of write to the side. I know that 1/2 times 8 happens to get me 4 times the square root of 49, and then 8 divided by 2 is 4. Square is going to give me minus 16. Alright, so I'm going to do all this now on my calculator. I know that this is going to be 4 times the square root of 49 minus 16. Well, 49 minus 16 happens to be 33. So we're just going to go ahead and put that all in. Alright, 33. Hit enter. And I find out that my B is this weird looking number. Now I could write this down, but I'm not. And here's the reason why. I've always told you never round till the very end of your problem. What you have in your calculator right now is capital B. Alright? So if you know what capital B is, we can plug everything in. I'm just going to put 22.9 blah blah blah. Alright? For now. And I'm going to multiply that by the height of my entire three-dimensional shape. Why? Well, one, I've already found the area of my base, which happens to be that 22.9 blah blah blah. And now I also know the height of my three-dimensional shape, which happens to be 2, so I'm going to multiply that by 2. Why waste your time in trying to plug this number back into the calculator when all you got to do is hit times 2? When I do, I get 45.95 blah blah blah. So, what's it tell me to do? The volume is blank, round to the nearest tenth as needed. Alright, so my tenth spot is right here. This 5 tells that 9 to go up. Because it's a 9, it automatically changes this 5 to go up. So that 5 becomes a 6, the 9 becomes a 0, and all these other numbers become a 0 as well. But because I was rounding to the nearest tenth, the only numbers that get dropped are all the zeros on this side. So it's going to be 46.0 inches cubed. Alright, again, a lot of work, but the premise remains the same. In order to solve for a weird shape like this, find the area of the base. In this case, we had to find the area of an isosceles triangle, and then multiply it by the height of the entire three-dimensional shape. Alright, now, this is the last one. This one is a really big deal because when we talk about base, we always talk about what's on the bottom, what's sitting on the ground. Well, in this particular case, our base is not going to be that simple. Our base is actually going to be a side. It's going to be easier to find the area of this side right here first. What am I talking about? Well, if we were to look at this from the top, we would simply get a square, alright, or a rectangle. But if we are to look at this from the side, we're going to get a very distinct shape. It's going to be a rectangle with a circle cut out of it, alright? That's the shape that you're going to get. So the question is, which one do I want to use as my base? Here's a hint. Use the one that's weird looking. This is too easy. That means, hey, this has got to be my base because this is the weirdo. And it's a good way of looking at it. If you could calculate the hard part first, then you can do the rest of it. Alright, so same rules apply. We're going to be using V equals base times height, the area of the base times height, but we got to find the area of this shape. So how do we go about doing that? Well, think back to one of the previous videos. We basically need to understand this. One, there's two things happening. First off, we have a large rectangle. So we first need to find the area of a rectangle. The next thing we need to do is find the area of the circle. Once we know that, we can subtract it because that hole is being cut from the rectangle. This is going to give us our base. Wow, that's a lot of information that you just had to digest, and I apologize on that, but I'm going to go ahead and tell you, it's getting ready to get worse. Alright, so what we're doing is we're going to find the area of this entire side. Let's start off with the easy part first. Let's work with the area of the rectangle. The area of the rectangle we simply know to be length times width, or base times height, or whatever. Well, we know that this measurement right here is 10, okay? And we know that the height of it, according to this, is 9. Well, that's easy. The area of the rectangle happens to be these two, length times width, or base times height, however you want to remember it. So it's going to be 10 times 9, which gives me 90 feet cubed. Now we got to find the area of the circle. Well, recall that the area of a circle is pi r square. So let's look at it. Here's my circle, okay? And it says that the diameter of this circle happens to be 1 foot. Well, I don't want diameter, I need radius. Well, how do we find that? Remember this, that radius is half the diameter. So basically we're going to say 1 divided by 2. When we do, we find out that our radius is 1/2, or we could just simply say 0.5. Alright, so now that we've got this, we can plug that in. And we can say, don't forget, our instruction says use 3.14 for pi. So we're going to say 3.14 times 0.5 square in our calculator. And it gives me this number, 0.785. So the area of our circle is 0.785 feet square. But I don't want the area of a rectangle. I don't want the area of the circle. I want the area of my base, which happens to be the rectangle minus their circle. So that's what I'm going to do. I'm going to put in my calculator 90 minus the 0.785. So 90 minus 0.785, and it gives me this number, 89.215. That happens to be the area of my base. 89.215 square feet. Am I done? No, we are not done. All we have done is just calculated the area of just this one side. We've calculated the area of this base. But we need the volume. Well, so how do we go about doing that? Well, the volume happens to be 89.215 times the height. Well, what's the height of the shape? Your instinct is to say, oh, here's the height of my shape. And in some ways you may be right, but here's the problem. We use this measurement as the height of our side, remember? So here's the thing. We've used that 10, so we can't use it again. We've used this 9, so we can't use it again. We've used the diameter, so we can't use it again. What does that leave us? It leaves us with the 7. Well, how is that my height? You have to remember that this is a three-dimensional object. It is not a flat object, just like this calculator. Just because, like for instance, this right here to you is my width and this is my length. But watch what happens. When I turn it on its side, that same length or this distance right here all of a sudden becomes my height. And then this is my length and this is my width. Just because I rotated it in a three-dimensional way, I changed the direction of those sides. So here's the point. Dimensions are relative, okay, to what you're looking at. This right here, even though it is the width of this object, if I were to rotate it in a three-dimensional way, it is no longer the width, but it becomes the height. So we just simply put it. And if that confuses you, remember this. You use this one, you've already used this one, you've definitely used that one. All that's left is this guy right here. So plug it in. So 89.215 times 7 gives me volume is equal to 624.505 according to my calculator. Alright, and what unit is this? It is, again, it is feet, and since it's a volume, it's cubic feet. Alright, so what does it ask me to do? The volume is approximately blah. It says to round to 3 decimal places. Hey, I've done that already. So my actual answer is 624.505 cubic feet. Alright, now, these problems that I've just gone over with you are probably the hardest problems in this entire set of homeworks. There are a few more that are very similar to this one, like this, that I'm not going to show you in this video because I don't want to make your life too easy. I want you to think. Alright, so I want you to try those on your own. You also have some word problems that are in there that are very similar to what we did at the start of the video. And again, I want you to look at those questions and think. Just because I've given you a word problem does not necessarily mean the procedure is changing. So like I'm saying, I'm not making it too easy for you because I believe and I want you to try them first. And that's pretty much it for this video and this module. This module is now complete. And I will tell you this. I'm not saying this to scare you. I'm just saying it as a statement of fact. Module 2 on geometry, quite frankly, is usually my worst test grades. And I beg you, please take your time with this material. Don't just try to fly through it. Make sure that you've got a good understanding of it. And if you don't, you know how to find me and we'll talk about it. Alright, I will see you next video. Bye.